All right, guys, May 4th today, section 10.7, only one section today. You guys get one section tomorrow too, so 2 days in a row. On Friday, we found measures of diagonals that intersect in the interior parallelogram. Well, actually, this was a previous chapter, but we've worked with intersecting lines before, basically, is what they're saying. Now we're going to be looking at segment lengths as they pertain to a circle. So if they intersect on the inside or the outside or on the circle, that kind of thing, what kind of formula do we have that's going to tie that together? And so what you guys are going to need to do is write the formulas down for each theorem. And once you have the formulas, the rest is algebra, okay? I don't think you're going to find that it's going to be too difficult. So chord segments, you're going to get two chords that cross on the inside like that, broken up into segments. That's all that is. A secant segment, the line segment's going to be from the outside, going to touch the circle twice. External secant segments, that just mean it's going to be outside the circle. And then tangent segments, tangent means it touches the circle once, if you remember. Okay, so here's the first theorem that you have to have. If you got two chords that intersect on the interior of the circle, the product of those two chord segments is equal. So AB times BC is equal to DB times BE. The product of those have to be equal. And so we're just going to, some will be unknown, some will be known, and we're going to set up an equation and solve. So for here, 8 times x should equal 9 times 12. That's ultimately what we're going to do. So a little bit of algebra, 9 times 12 is 108, divided by 8 gives me 13 and a half, done. All they asked me to do is find x. I don't need to plug it in to find a line segment, so we're good to go. All right. Now, this one's going to require a little bit more algebra, okay? If you've done algebra 2 already, so this shouldn't be too bad, but so x times x plus 10 is equal to x plus 2 times x plus 4, okay? Well, that's going to require multiplying some things out. So over here, x squared plus 10x, and then foiling over here, if you remember this. So x times x times 4, 2 times x, 2 times 4. Okay, if you work that out, of course, the left side is x squared plus 10x. The right side is x squared plus 6x, because you got 2x and 4x, and then plus 8. And they were kind of nice to you on this one, because if you subtract x squared from both sides, you lose the x squared, so you don't have to worry about solving a quadratic. Subtract 6x, divide by 2, or divide by 4, and you get x equals 2, sorry. Pretty straightforward from that point, okay? Pause your video, give it a shot, and then we'll go through it together here. All right, so I've got a couple of chords that intersect on the interior. The product of the parts is equal, so 5 times x is equal to 10 times 8, okay? 5 times x, of course, is 5x, 10 times 8 is 80, and 80 divided by 5 is 16. So if you guys got 16, you're good to go. Okay? Let's do the algebra on this one. So I've got x plus 4 times x plus 20 is equal to, x plus 4 times x plus 8 is equal to x times x plus 20. Okay? So we're going to multiply this out, FOIL this side. This side is x squared plus 12x plus 32. The right side is going to be x squared plus 20x when you distribute. If you subtract x squared from both sides, you're going to lose your x squared. So I get 12x plus 32 equals 20x. I'm going to subtract 12x from both sides. Okay? And then when I divide by 8, 32 divided by 8 gives me 4. Okay, so if you did that right, give yourself a pat on the back. Okay, really similar situation. They just want to have the numbers written in here. So biologists often examine organisms under microscopes. The circle represents the field of view under the microscope with a diameter of 2 millimeters. Okay, so this segment here is 2 millimeters. Determine the length of the organism if it's located 0.25 millimeters from the bottom of the field of view. So this is 0.25. That makes this segment up here 1.75 because the whole circle had a diameter of 2. Okay? And then each of these segments we're going to just let be x because we know a diameter, if it is perpendicular to a chord, it bisects it from a couple sections ago. Okay? So we're going to see on the next screen then, x times x is going to be 1.75 times 0.25. Okay? go. So now to undo x squared, I take the square root. Normally I do plus or minus, but in the context here, a length can't be a minus, so we're just going to deal with the positive version of this, about 0.66, okay? This is just checking to make sure it works, and it does. All right, so give this one a shot, you guys. All right, Phil is installing a new window in an addition for a client's home. The window is rectangle with an arched top called an eyebrow. The diagram below shows the dimensions of the window. What is the radius of the circle containing the arc of the eyebrow? So if I continued this circle around, what would be the radius of that? Okay, so here's the thing. This piece here would act as a diameter. I don't know where this circle is going to come back around, but if this part's 2, and we'll call this x, I'm not sure what the rest of the diameter is going to be. It was 12 all the way across. We said a diameter bisects a chord if it's perpendicular. So this is going to be 6 and this is going to be 6. So I've got 2 times x is equal to 6 times 6, okay? So 2x equals 36, x equals 18, okay? Well, now think about that. 18 is just a portion of that diameter. The entire diameter is the 18 plus 2. So the diameter is 20. They asked me for the radius. Radius is half the diameter, half of 20 is 10. So you just got to read that one carefully and be real careful about how you solve it, okay? All right, secant segments. Now, it's really tempting to do this one wrong, so be careful about how you look at the example and how you read the theorem. It says that the external part times the length of the entire segment. So that would be AB times AC, the whole length, okay? And AD times AE, the whole length. So make sure you're taking that whole length into account. It's really tempting to just multiply the adjacent parts. Outside part times whole length. I can't say that enough. Make sure you get that example in your notes. Okay, so here this would be 8 times 8 plus x equals 10 times 34, okay? So algebraically you distribute this. 10 times 34, of course, is 340. Subtract 64, divide by 8, 34 and a half, okay? Okay, so give this a shot, and then we'll try it together here. So I've got the external part here, which is x, times the length of the whole secant segment, which is x plus 24. And that's going to equal the outside part, which is 25, times the length of the whole thing, which is 52. Okay? So algebraically, I distribute that x. And 25 times 52 is 1,300. I only know that because I worked it out prior. I'm not doing this off the top of my head. Okay? So now I've got a quadratic. I've got to get 0 on one side. Okay, so now you've got some options. We can factor this. It's going to be a little bit tricky to factor because there's a lot of factors at 1,300. I have worked that out and I'll show you. Or you could use the quadratic formula. That's up to you. So I'm trying to find numbers that multiply to 1,300 but subtract to 24. Okay, and it turns out 50 and 26 multiply to 1,300 and subtract to 24. I need a positive 24, so I'll have that be a positive and that be a negative. So at least initially, I think, hey, x could be negative 50 or 26. But in context, negative 50 doesn't make any sense, you guys. So we're going to throw that one out, and we're going to keep the 26. Okay? All right. One more example. So I've got a tangent and a secant. The secant part's the same. Exterior part JL times the entire length JM. Okay? And whoops, the tangent part then is squared. That JK is just going to be squared. So keep that in the back of your mind. Write that formula down as it pertains to this example. So in this case, I've got 12 squared equals x times x plus 2. Okay? And so, you know, I can think of that as 2x plus 2, and 2x times x is 2x squared, and 2 times x is 2x. 12 squared, of course, is 144. I've got a quadratic, get 0 on one side. Okay, they divided by 2 first. Okay, so I get 0 on one side. What numbers multiply to 72, subtract to 1? I think 9 and 8. okay? Negative 9's not gonna work in context, but I think 8 will. So we're gonna use the 8, we're gonna throw out the 9, okay? All right, you guys give this one a shot. All right, so here's what we're gonna do. The tangent part is squared, and then we're gonna go exterior portion times the entire thing, 20 plus 25, which is 45, okay? So x squared, 20 times 45 is 900. And then I gotta take the square root, okay? Now normally I'd go plus or minus 30, but again, negative doesn't work in context here. So we're gonna just deal with the positive version of that, or the 30. All right, that's it, you guys. So page 754, look at this, 7 through 21 odd is all I'm asking you to do. Everyone should have this one done by noon, probably. Certainly before that if you're up. Good luck, and we'll see you tomorrow.